In double-entry accounting, every transaction has two equal and opposite impacts. Debits equal credits, the books must balance. And if they don't, you know immediately and exactly where. Nexsus takes that same discipline and applies it not just to your data, but to the structure of the data itself. Underneath every record is a set of mathematical equations that must always hold. Break one, and the right is rejected, and the substrate names the exact equation that failed. It starts with one universal law, the closure equation. In plain terms, nothing can point at something that isn't there. Every reference, a record to its model, a sale to a customer, must resolve to something real. Everything that follows is a specialization of this one rule. If you're a database person, you'll recognize the shape of this. Referential integrity. The difference is scope. A foreign key protects references between rows. In Nexus, the schema itself lives inside the substrate, so closure reaches the meta layer. Not just this sale points at a real customer, but this field points at a real definition, this record at a real model, this label at real vocabulary. The schema is data, so the schema obeys the same mathematics. In accounting, nothing is posted without an account in the chart of accounts. In a library, no book sits on a shelf without an entry in the catalogue. The Nexus registry works the same way. No record exists without a registered home. And the catalogue isn't paperwork, it's enforced. Now the equations, tier by tier. First, identity. Every record has one unique 40-digit identity, guaranteed well-formed. Reuse a code, and it's refused. Every search vector must be exactly the right size, so semantic search always compares like with like. And nothing essential is ever left blank. Second, schema. A model's shape must equal its declared fields. As a set, so there's no silent substitution. Every record's kind must be one the system recognizes, and the reserved positions inside every identity are zero-filled, so nothing hides where it shouldn't. Third, structure. The library rule, made literal. Every field and every record must belong to a model that actually exists. File a sale under a model that was never created, and it's refused. No homeless data. Fourth, the data itself. Every column you fill in must be one the model declared. Send a discount field the model never defined, and it's rejected, naming the key. A restricted field can only take its allowed values. And even the system's own naming vocabulary is governed. A misspelt label is caught before it can save. Fifth, relationships. A link can only join records that exist. Attach a sale to a customer who was never created, and the reference is refused. And every link must be a recognized kind of relationship, matching the identity encoded in the link itself. A placed edge can never secretly be something else. Sixth, the catalogues. Before a new model is born, it must be registered, with an owner and a purpose. So the workspace never fills with models nobody owns. And the catalogues stay clean. Exactly one active definition per type, no competing truths. And seventh, history. Nothing is ever truly deleted. Try to hard delete a customer and their order history, and the substrate refuses. Records are superseded and archived, never erased. The audit trail is permanent. And alongside these run more still. Value typing, versioning, name uniqueness, each another equation that must balance on every write. Here's what makes this more than a schema. Every write is checked against the full equation set before it commits. If it would break a law, you get back the specific equation that failed, as a stable error code. It's an API contract, not a Mystery 500. And if the substrate ever found itself inconsistent, it will not write on top of an imbalance. At the center is a discipline we call six-way reconciliation. Before any record lands, 6 independent views of it, from its identity, through its content and its search vectors, to the sentence it renders of itself, must all tell the same story. Any disagreement and it's rejected. 6 witnesses, 1 verdict, enforced inside the database engine itself, not an application code a bug could skip. Now, if you're thinking, my Postgres already has foreign keys, it does, and Nexsus uses them hard. The difference is coverage. Conventionally, foreign keys protect rows. The schema lives outside the data. Naming is a convention, history is whatever your last update left behind. Here, schema, vocabulary, versions, and links all live in one governed graph. So the same machinery that stops an orphaned order also stops an undeclared field, an unregistered model, a misspelt label, and a silent delete. None of this is exotic. It's PostgreSQL, a deliberately tiny storage core, small enough that its integrity can be proven. Meaning-based search runs on pgvector. The semantic embeddings come from Voyage AI's Voyage 3 large model. 3 vectors per record, 1 structural and reproducible, 2 semantic. The surface your AI talks to is the Open Model Context Protocol over FastMCP, with per-customer OAuth and database-level isolation. Deployed, fully managed on Railway. So picture the equations as the stones of an arch. No single one carries the weight. But keyed together, the closure equation as the keystone, they turn the downward force of every write into something the structure carries. Not checks bolted on top. The arch itself. That is how the equations enforce the substrate. So why does a mathematically balanced substrate matter for AI agents? Because agents are stateless. They forget. And increasingly, there's more than one of them working the same thing. A shared memory is only trustworthy if it can't be corrupted. No agent can leave it half-written, and every agent reads exactly what the others committed. That's what the balance equations guarantee. Let's watch 2 agents prove it. 2 agents, 1 shared workspace. First, Claude files a research note into Nexus, a finding and its source. Now, ChatGPT, a different assistant, with no shared history, reads that note back exactly. No handoff, no copy-paste. It adds a recommendation and links it to the finding, a complete connected story with no dangling reference. And it's really there, in the shared workspace, the finding, its source, its status. 2 agents, 1 memory, provably consistent. Neither could corrupt it. Neither could leave it half-written. Not a pile of notes and AI hopes is consistent. A memory layer that is provably consistent. Nexus.